For today's lecture, we're going to be going over an introduction to data visualization in R. So for the in-class exercises, this is building on our data types and figures lecture. And for the assignments, it also builds on our dplyr lecture. So if you need to refer to these, please look at those lectures or assignments from before. We have three different data sets that we're going to be using today. We have the fisheries data set we have been using for examples of community assemblage, multiple species, looking at length and weight. We have a forestry data set on the height, volume, and girth of trees. And we have an iris data set on sepal length, petal length, and width, and different species for you to use in that assignment. Today's goals are to review the types of figures and data that are appropriate for each figure, understand the difference between global and aesthetic parameters in a figure, as well as data positioning, and then write code that creates basic figures and alters those figure parameters and arguments. As an introduction to visualization, we're moving on from the data wrangling into the visualization aspect in this course. And as we progress further with visualization, we're going to be incorporating that data wrangling into those visualizations and also what you're going to be doing in the assignment today as well. So we're going to be using some of those functions and building on them in the ggplot2 package for visualizing data. This is a graphing package from the Tidyverse, like the other packages we've been working in. It's an incredibly powerful tool for creating publication quality figures and altering different aspects of the figure you make, which you can look at color, you can look at annotating, you can do multiple types of figures, and you can also integrate dplyr into ggplot, so our data wrangling and manipulations into the visualization. So if you remember from dplyr, we use the pipe, the percent greater than percent, to say, do this to your data, then do this, then do this, and you can just keep compounding onto your data. You can do the same thing in ggplot, but instead of the pipe, use the more simple plus sign. And you can actually pipe directly into ggplot2, which we'll do at a future date. So ggplot builds on code to say, do this to my figure, make it a scatter plot, add a line, add text, add a legend, make figure appealing in these different aspects. You add with that plus sign specifically. So it reads very nicely when you type out everything. So let's load our packages of ggplot2, dplyr, and reader, and we'll load in that fish data like we have been doing before. So just run that code to load it in. And we're also going to load the trees data set. And this is an inherent data set in R. So to call it, you just say data and then put trees in those parentheses. If we want to look at what that tree data set looked like, we can use structure or glimpse or anything. So str trees. We've got 31 different trees in here, and the three variables are girth, height, and volume. You can see how to spell them there. So the syntax for graphing in ggplot is to specify your data set and variables from that data set within the ggplot function. However, no figure is going to be created with only that ggplot function. You must specify a geometry for the plot, scatter plot, line plot, bar chart, etc. And that's going to be in the second line of code. So here's our basic syntax. Specify the ggplot function, specify your data set. We're going to use the trees data set, comma, AES. That means aesthetic. And within the AES wrapper, we put our variable height. That's one of our tree variables here. Close off those parentheses, add that plus sign, and specify geometry. We are only adding one variable here, so we're going to do a histogram, for example. Geom underscore histogram, open parenthesis right now. So we've specified ggplot and our geometry, and we get a basic histogram. R automatically counts what you are looking at with your variable. So for height, this is number of trees with these specified heights. So count on the y-axis, height on the x-axis, basic histogram that we can then build off of later. So histogram is just one specific type of figure, and there are so many different types of figures that we could look at in ggplot. So below are some of the basic figure types we discussed in prior lectures. And again, this is not an exhaustive list of figure types. I want you to pause the video and review this information on your own, specifically the appropriateness of variables and figure types, as well as the different types of plots you might be using in the assignment today. And what you'll notice for these is that the syntax is always the same: ggplot, dataset trees, specify one or two variables, but the geometry changes. So scatterplot, geom underscore point. Line plot, geom underscore line here to get a regular line graph. So go ahead and look at this information and move forward with it. So to unpause this, we're going to be looking at specifically the aesthetics of these data and the figures in them. So we can alter essentially every aspect of a figure or graph: the color, the shape, text size, point size, lines, etc. And there are two ways you can manipulate these graph aspects. So you can use what's called global or aesthetic, or AES, parameters. These global parameters affect the entire plot uniformly. So you make all the points red, for example. Aesthetic parameters affect only the objects in the plot you are interested in manipulating with the code. And it's specified using the AES wrapper like we have for the variables. And it allows you to do a lot more interesting things with the plot, like changing the color of points based on species or habitat, for example. So for this first example, we're going to get into a scatter plot. We are specifying the ggplot function. Here I have data equals as just a reminder for you that this is the argument within this function. You do not have to have data equals. You do not have to have mapping equals. But if it helps you keep it straight, go ahead and use it. Data equals fish. So our fish data set we brought in, and we are looking at the variables in AES here of length and weight. We want to look at a scatter plot of length and weight. So we have the plus sign and say geom underscore point for that scatter plot. Here we are making the points red. The shape of them equals 12, and that's a specific shape in here. There's about 25 different shapes you can do. And the size of those points equals 1. So if we run this code, we can see that every single point, the color, the size, and the shape are all the same because we made them global parameters. So they're all uniformly the same. Contrastingly, we can do aesthetic parameters. We're going to, for example, change the color of the points based on species. This first line is the exact same thing, copied and pasted from above. ggplot, data or fish, mapping, length and weight variables. We again specify our geom point. We are having shape and size be global parameters. They will be uniform across all points. But here we specify AES again, just like we have for the variables, and we put color equals species. We're putting a factor or a categorical variable here instead of red or blue or anything. We run this code and we can see R automatically created a legend. And based on this legend, we can easily or more easily see that the colors of each of these species differ from one another. In this figure, we see pink, blue, green. We can alter those colors in the future using more aesthetic approaches in R Color Brewer, and we'll be doing that in a later lecture. So we can change many aspects of these figures by different parameters globally and aesthetically. I want you to pause right now and think about what would happen if we change the color by a continuous variable like length. Do it And then think about, is that an appropriate way to visualize the data, and why or why not? As our second example of aesthetics, we're going to be using the same syntax we've been doing, the same exact figure, but now we're going to be using aesthetics for two different parts of this figure, the color of the points as well as the shape of the points. We are keeping size as a global parameter here, but to do multiple effects or aesthetics of this figure, put AES and then specify your color equals species, just like we had in the previous figure. And now we put shape equals species as well. We run this. We see the sizes are the same, but the point size or point shape and color are all different, and that varies by species. And as a bit of live coding here, if we want to do something looking at transparency, so let's say we want to change the transparency to equally across all these points. So if we have our length and weight of our variables, we are doing geom point, and we are saying alpha, which is transparency, it's not intuitive, equals 1. And here all of our points are uniformly the same dark gray or black color. And let's say we want to change transparency by species then. Why don't we just copy and paste this? And for transparency to be changing by species, we have to have that AES wrapper. Make sure you're adding that extra parenthesis. And alpha here doesn't equal a numeric value now, it equals species. It equals that categorical variable. And here we can see now that the grayscale variation changes for these different species, so that transparency of that point is shifting by these species because we specified it aesthetically. Our final part of this is to look at positioning of data in here. So you can arrange the position of your data in multiple ways. This is especially helpful for scatter plots and bar charts to look at comparing data across groups. So there's 5 main positions. Each of these has an explanation of what they are, which is more helpful paired with the actual visualization. So there's identity, jitter, stack, fill, and dodge. Here we're doing the same exact syntax for every single figure. We're just changing the position. So we've got ggplot of our fish. We're looking at species, and we are color coding by pool or where they were captured in the river. We're specifying a geom bar geometry, and our position equals identity for this first one. Here we can see that the colors really overlap here, and we can also see that we just have colors on the outline of the bars, and that's because color is here instead of fill. Color is only the outline of bars, but if we do fill, it fills in that bar with a specific color. So what we can see here is that these bars are overlapping with one another. We can only see pool 8, LG, and OR. That's not helpful for us. If we look at jitter, same exact code except position equals jitter, we can see all of the bars except they're all sporadically placed, and this is gobbledygook. This is not helpful for these data specifically, but it might be helpful for a scatter plot to pivot some of those points that are overlapping with one another. We can do a stacked bar chart where it takes the raw count of each of our species by each capture location or pool, and we can directly compare across groups, although this might be hard for direct comparison, but we can kind of estimate how many are coming from these areas. If we do position equals fill, it automatically creates a proportion where we can look at the proportion of individuals collected from each pool for each species. And this could be a direct comparison across these groups. And then the one I like to use the most because it's a very easy direct comparison is position equals dodge. When we look at this, we see raw counts of bars that are next to one another, so you can easily compare across species and across these pools or sample locations for direct comparison. So this brings us to the assignment. Please remember to annotate code, do the code, look at the iris data set, look at that fish data set, answer those questions thoroughly. And if you have any questions on any of them, please reach out to me for assistance.